So let's talk about quadratic functions and their properties. The first thing to know is the standard form of a quadratic or a parabola, and that is our classic y equals ax squared plus bx plus c. Something else to know about it is the actual graph, if it's going to open upwards like this, or if it's going to open downwards. So it's really the direction in which the graph is going to approach either positive infinity on the y or negative infinity on the y. And we can determine that is if our a value right here is greater than 0, that is going to open upward, and if it's less than 0, if it's negative, it is going to open downward. Some other components to be aware of are the vertex and the axis of symmetry of a parabola or a quadratic graph. So the vertex is the point on the graph which is either a minimum or a maximum depending on if it opens upward or downward. That goes straight through the axis of symmetry. So the axis is this invisible like dotted line that actually splits the graph in two, where it would be reflected over this axis of symmetry. So every parabola has one, and it always crosses through the vertex. Now we can actually algebraically find the axis of symmetry and the vertex if we're given the function, and I know my a, b, and c values. I can actually plug that into this equation right here, which is x is equal to the negative b value divided by 2a. That will give me my axis of symmetry, which is an x equals some value line that's going to pass through the vertex. So the vertex is always a point, so that's going to be a set of coordinates where the x is the axis of symmetry, which makes sense because that is x equals negative b over 2a, and the y value is going to be the f of that number, which also makes sense because it is the function of this x value right here. Something else that's very important algebraically is the use of the discriminant, which is found underneath the radical in the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That b squared minus 4ac is actually going to tell us the nature of the roots. So if underneath that radical it ends up being 0, we're going to have one real root that's going to touch the x-axis only once. If it's greater than 0 or it's positive, we're going to have two real roots, and that's going to touch the x-axis twice. Whether that opens upward or downwards, doesn't matter. And then if it's negative, we know that we can't have a negative radical in the real number system, so it's going to have no real roots. So it will still graph, but it won't touch the x-axis because it doesn't have a real number value for x. And something else that's very interesting is that if my discriminant actually ends up equaling a perfect square, like 0, 1, 4, 9, 25, etc., we're going to have two real rational roots. So that's going to be those really nice whole number, pretty roots that end up out of the discriminant. So let's take a look at an example. I'm going to choose the function y equals x squared plus 6x plus 9. I know that's a quadratic based on this first term here, and I know that that's going to create a parabola. So even if I don't have this graph here, I can find the axis of symmetry and the vertex pretty easily given the information that I just learned. So what I need for that is I need to know my a and b values. So my a value here is going to be 1, and my b value is going to be positive 6. So remember from a couple slides ago, the axis of symmetry is an x equals something line where it's negative b over 2a. So if my b is 6, that's going to be negative 6 all over 2 times 1, which is negative 6 over 2, which is just negative 3. So my axis of symmetry is going to be the line x equals negative 3, which I can see if I graph it over here. So my x equals negative 3. So that means that my vertex is going to have an x value of negative 3. So I'm going to then plug my negative 3 back into my original function to figure out my y value when x equals negative 3. So that actually ends up being y equals 0, which is very nice. So that's going to hit right on the x-axis, which is also going to be an x-interceptive line. So that means that my vertex is going to be negative 3, 0. So another thing I can actually do here is determine the kind of roots or x-intercepts I'm going to have using the discriminant. Now, I already found what the vertex is going to be, and I know that that's going to be an x-intercept, but let's prove that using the discriminant. So to remind you, the discriminant's that thing under the radical in the quadratic formula, so that's b squared minus 4ac, where my b is 6, my a is 1, and my c is going to be 9. So my discriminant ends up being 0, which is going to be right here. And if I actually use chart, I see that if b squared minus 4ac is a perfect square of 0, especially if it's one root, if the discriminant is 0. So it's only going to hit it in one place, but it's one of those nice roots that works out to be a whole number. One last thing I can do is I can actually find the quadratic function or the equation given the vertex and another point, or the y-intercept in this example's case. So what it's talking about and what we're going to need for this is the vertex form of the parabola or the quadratic. So the standard form is our ax squared plus bx plus c, but the vertex form actually takes into account the vertex, which we're going to call h comma k. So you take the a value, that's the same, and then we subtract the x value from the vertex here, so that's still giving us that x squared component, and then we're going to add the y value from the vertex. So that is actually going to give us a manipulation of the standard form. So the first thing I'm going to do in this problem is actually find the point at which that y-intercept lies. So that means that my x value is going to be 0 and my y value is going to be -3. So now I have 2 points in which to plug into the vertex form. So the first thing I'm going to actually look at is the vertex, which is h comma k. So I know that my h is going to be 1, because that's that value, and my k value is going to be -5, but I notice that that's going to take care of those two things. But then I also have this f of x, this a, and this x. So that's where this second point, or this y-intercept of -3 point, is going to come into play. So that's going to help me out, and that's going to give me my f of x value and my x value. Now my x value is going to be 0 from this point here, and then my f of x, or my y value, is going to be -3. So the only thing that's left to solve for is a, which we'll plug back in to get the vertex form of this equation. So if I plug in my f of x, that's going to be -3, that's going to give me some value of a, x is 0 minus h, which is 1, squared, and then plus k, which is actually -5, so that's -5. So at this point, what I have is -3 is equal to a minus 5, so I'm going to add the other 5 to both sides, and I end up with a equals 2. So now I have the information that I need in order to plug it into this vertex form and actually come up with the quadratic equation for this specific example, because a is 2, h is 1, and k is -5. So I'm going to plug all that information in, I'm going to expand it, and it's going to give me the quadratic function that I'm looking for. So once I expand everything, I combine my constants and all that good stuff, I end up with the final quadratic formula in the standard form that we're used to as 2x squared minus 4x minus 3.
And that's going to do it for this video. Thanks for watching.